Hey everyone, thank you for joining us. We are RobotLAB, and this is our AI Lab webinar. We are going to discuss different topics such as machine learning, humanoid robot interaction, smart transportation, and Industry 4.0, all of which are different components to our customizable AI labs that we integrate in K through 12 settings as well as higher education. I have a few colleagues with me here that will be introducing themselves and talking about what they do.
My name is Amy. I am the K-12 sales manager for RobotLAB.
My name is Mitchell Bergman. I am the solutions engineer here at RobotLAB.
So what I wanted to bring you all here is just to kind of go through how we're seeing it within the market space. The AI Lab can be all inclusive of different students of different age ranges, but Mitchell, I've seen you install a lot of these, so I want to see from your standpoint how you're seeing it implemented. What are some successes that you've seen, and how the training has gone in training the teachers that are using it. Also for Matt, I'm just curious to know how you're seeing it in your element as well. So Mitchell, can you kind of share what you're seeing?
Yeah, so essentially what we're showcasing here is our AI lab, and what I'm seeing, what I do on the integration side is we're essentially given an empty room at a school, at a library, at a science center, you name it, we're everywhere, and we outfit the school with basically everything you see here. So from the furniture to the computers to the robots, we do all the training, all the implementation, all the lesson plans behind it, everything, right? So we're basically giving these schools a turnkey solution to creating a robotics and AI machine learning course for many age ranges, right? We have multiple different robots for all different age groups, all different reading, coding, math skill levels, and we are creating a progression from kindergarten through to K-12, leading into higher ed, research, things like that, right? So, what I'm seeing from the schools is they do need something like this in place, right? We're seeing a lot of, math and science teachers who are now becoming computer science teachers and machine learning experts, right? Without any prior knowledge or prior experience, right? So something like this is really important to them in terms of getting everything they need right out of the box. We give the teachers, all the training that they need in terms of how to use the robots, what they're capable of, how the students are going to use them, things like that. And then, of course, we provide the lesson plans and activities for them to follow for the students to start gaining the knowledge and gaining those skills.
Also, I just wanted to add in the importance of being able to transform an existing space into something that is future-proofed, making it easier for students and teachers to implement in all different subject levels, and be able to kind of note on those AI concepts and computer science concepts and potentially even CTE concepts in a way that makes it exciting for them. And then also reviving any potential museum spaces or libraries to gain more interest from the public as well. I think that's a great opportunity for this space.
Yeah, so basically everything that we install is, modular in a sense. We try to tackle some of the main industries that we're seeing the rise of AI and robotics in. So, Industry 4.0 is going to be collaborative, like robotic arms and programming those. It's open-ended enough so that when new, applications arrive or new types of integrations are available, we can easily integrate that into our program, and we can provide that to the teachers as well. Smart transportation is another one, whether that's drones or autonomous cars, things like that. We teach them all the basics of that. And then, of course, humanoid robotics, human to robot interactions. That's ever changing. That's one of the biggest industries that are kind of booming right now. Our robots are, pretty capable of taking care of introducing students from a young age to the concepts of how to communicate with a robot, how to program a robot, how to use external tools with a robot, things like that. And as time progresses, our AI labs will also progress, but it will be easier to modify in the future because you will always have that base standard of what industry are we serving. And when that changes, then we will adapt as well.
Yeah, I think it's important to note and preface all that by saying that, the reasons that we do this is we're passionate about the development of students in this day and age. There's a massive, robotic wave that's coming in the real world, and we want kids to be prepared for this. So students going into college and college students going into the workforce, being prepared to interact with these robots as they're being implemented more and more in everyday life. And so it's super exciting. We start, at an early age, K through 12, to get kids excited, to show them that, it's not scary, that it is for everyone, and that they are capable of learning these things. As Mitch mentioned, whether it's with a humanoid or a robotic arm that they may see in a workspace in the future, in a warehouse, automation, things like that. And so really just, bridging that gap and being passionate about getting these kids what they need to have a successful future and know how to interact with these machines as they integrate more and more into everyday life.
And Matt, can I also ask you, since you're the expert at your field, how are you seeing the higher education market using robots, and how is that being scaled up in that kind of university college setting?
The more of what we're seeing in higher education are the kind of different setups. So the main thing that they're looking at is like what we have right over here with the MG400 workstation, as I mentioned, preparing kids, but college students for a future in the workforce. So it's training them data analytics, it's machine learning, teaching them all that. But the main things that they focus on are, as Mitch mentioned, smart transportation, Industry 4.0, with a little mix of the humanoid, the human-robot interactions. And so those are the main points that these professors and universities like to touch on. They're the main ones that I'm seeing being implemented into lab spaces across the U.S.
So, I think we've all seen the quadruped robots in that sort of setting on the social media of the world. So how are you seeing these quadruped robots and then unmanned ground vehicles kind of being used as well in a research setting?
Yeah, so as you mentioned, it's a lot of research applications. They are using it to learn how to code, whether it's through Python or any type of other interface. But the main goal is, to really dive deep into these technical applications with the like you mentioned, the robot dog. So autonomous movement, how can we get it, write some code to get it from point A to point B, using those in different fields like search and rescue. And as I mentioned, autonomous movement is a big thing. And so the possibilities really are ultimately endless if we're equipping them with what they need to learn and move forward.
Yeah, and I think we live in a really great world right now. It's exciting in seeing this open up to the business world as well. We're seeing delivery robots being deployed in restaurants, cleaning robots being deployed in many different places, restaurants as well, hotel settings. Senior living facilities are using humanoid robots for interactions with the residents there. So, I really do think it's going to be prevalent in these children's futures and in their future workforces and settings. So it is interesting to see what path they might take. If they are a really good programmer, or the customer interfacing, or the development and support of that, or the repairs. I think there's a lot of different channels that they can go through in their workforce, and I think that's exciting to see as well.
Yeah, just to kind of relate, most of the stuff that you work on, Amy, how it translates to the research. Um, a lot of the autonomous vehicles or like the robots that we provide to the young students will show them how to integrate, external sensors like the soil moisture sensors, light sensors, GPS, things like that, right? Shows them that it's not scary. It's here's all the tools that you can use, do whatever you'd like with it, right? Then once they get to college, they can take the bigger unmanned ground vehicles, be confident in saying, you know what, I have an idea of what I want this robot to do. I want it to go, test all the soil around my farm and determine what nutrients it needs and then deposit those nutrients, right? That's what's happening in industry right now, as well as in college research programs is, you can use the drones to fly over, check on the status of crops, and then you can use an unmanned ground vehicle to patrol and test the soil itself. We've been seeing people using these vehicles to check on solar farms, do search and rescue, go places where men cannot go.
That's true. So you're protecting the first line of a human interaction with a robot. And also I like that you discussed the agriculture, let's call it smart agriculture, as far as being able to use these robots and technology to a different level than we used to be able to. Hydroponics is very prevalent in the marketplace now. In addition, you said using drones for agriculture and different unmanned ground vehicles to do surveillance as well. Now I want to bring up the topic of AI. We're hearing this every single day in our lives, within the RobotLAB world, but also on social media, in the news. It's a huge, topic now. So how are we incorporating from the STEAM topic from prior years to transitioning to AI, and how does that translate in education?
Yeah, absolutely. So, for the longest time, AI and machine learning research was done at the higher ed level, right? It was strictly college, universities, or professional, organizations that were doing the research on AI and machine learning and its capabilities. Now that all the tools are out there for everybody to use, and it's machine learning and AI, applications that you can use anywhere, it's starting to become more acceptable to be learning about this at a younger age, right? And so what we're trying to do in our labs is teach the basics of it, right? It's kind of to the point where they can start learning the basics of everything, and then by the time they get to the grade level or the expertise to develop their own applications, they'll be ready. So things like what do you need to create a vision system, right? So we provide robots that have cameras and have vision training systems, right? So that you can use that robot with a vision system to complete tasks, right? Like a robotic arm, for example. You can have the robot pick out shapes, sizes, colors, objects, things like that, sort them, palletize them, you name it. Speech recognition and natural language processing, things like that, right? So our humanoid robots are capable of, teaching students the basics of natural language processing. Eventually, you can teach them the basics of large language models and how to integrate that with humanoid robots.
I've heard before you tell me about how to explain AI, and I thought it was interesting. So help me describe this to them. Basically, we are training AI to become more like a human in different ways. So can you kind of explain that?
Yeah, sure. So the goal of artificial intelligence is to mimic or, be better than humans and their human senses, right, in a sense, right? So when it comes to seeing, like I said, it would be using a camera and machine learning algorithms for computer vision, right? So AI is going to be the kind of the end goal, but machine learning is the way you actually get the robot or get the model to actually produce the right output, right? And so, like I was saying, with vision, you would use a camera plus machine learning algorithms to give it, computer vision. right? To mimic listening, you would use the natural language processing. You compare that with the large language models to have dialogues. For touching, right, you have tactile sensors, and kind of the way robots are being developed now is that they can read the data from their tactile sensors to determine how much pressure they should be putting onto objects as they're grasping it, right? And so that's kind of what we're trying to emulate here in our AI labs, of course, is to take those concepts, break them down into the fundamental pieces, teach the kids how to recognize what is needed, and then teach them some of the programming concepts behind how to create the application themselves using pre-trained models, or eventually training their own models on whatever application they see is needed out in the real world.
Hey guys, thanks again for joining us here at RobotLAB's AI Lab webinar. Looks like we've got a handful of questions that we're going to be answering in this next segment. We just wanted to thank you again for all the support, and again, if you have questions after the fact, you need a consultation or a quote, please feel free to reach out to us. We'll be happy to help you.